In this video, we will get the value of the relative atomic masses of the subatomic particles that are proton, electron and the neutron. The relative atomic mass unit that is called as AMU is basically 1/12 of the mass of the carbon atom. That means mass of one carbon atom. So first we need to calculate the mass of the one carbon atom, and then we can divide with the 12 to get the value for the atomic mass unit. Okay, so we know in case of 1 mole, the mass of the 1 mole of the carbon atom is 12 gram, but we don't know the value of the mass of the one carbon atom now, but we know in 1 mole there are 6.022 into 10 raised to power 23 that particles that are present. Just to calculate the value of the one carbon atom mass, you will divide 12 gram with the number of the atoms that are present. In this way you will get the mass of the one carbon atom. Now this is the value of the mass of the one carbon atom. Okay, now we are basically interested in calculating the value of the 1/12 of the mass of the carbon atom. So you can divide the mass of the one carbon 12 with the 12, but when you will divide it, you will get the answer of 1.600754 into 10 raised to power minus 24 gram. Now you need to convert them into kilogram by dividing it with the 1000. When you will divide it with the 1000, you will get the answer of 1.60005 into 10 raised to power minus 27 kg. Now this is the conversion formula, which you can see that the mass is in atomic mass unit is the mass of the particles in the kg divided by the 1/12 of the mass of the carbon atom. This is the mass which we have calculated. Now we already knew about the the masses of the proton, electron and neutron in the kilograms. Here you can see the mass of the proton in the kilogram is 1.67 into 10 raised to power minus 27. When you can divide it with the 1/12 of the mass of the carbon atom, that is 1.6005 into 10 raised to power minus 27, you will get the answer of 1.0073. Likewise, the mass of the neutron in the kg is this one. You will divide it with the mass of 1/12 of the mass of the carbon atom, you will get the answer of this. And similarly, when you can divide the mass of the electron with the 1/12 of the mass of the carbon atom, you will get this. Now you can see all the mass of an atom is due to the proton and the neutron, and the mass of an electron is so much minute that you can almost neglect it. So that's why we can say all the mass of an atom is concentrated inside the nucleus, not outside the nucleus, and we can say both have the same magnitude of the mass. Thank you so much for watching the video.